We are getting ready for our second session. As a reminder, this event is on the record and we are recording. The QR codes that you're seeing up on the slides there have information about our events and our membership. Then after this session, we are going to take a 10-minute break. We can go ahead and bring session 2 up. I also want to thank our lead and impact sponsors, Pang and Yum 2002 Trust, Kenson Ventures, and Tencent. We cannot do this event without all of them, and they have all been long-term sponsors and supporters year after year. Please welcome now our Session 2 moderator, Asia Society Northern California Advisory Council member, Orville Schell. He's going to introduce our panelists for our session titled, How Semiconductors Make Taiwan One of the Most Important Places on Earth. Orville.
Well, thank you, Margaret, and it's great to be here. Whereas you had a rather nice deep dive with Wendy Cutler, we have 4 comrades here, and we're going to have to be really extreme in our brevity to also get to questions from you. So our topic is the question of how semiconductors play into the whole geopolitical scene that we find boiling in Asia. China buys more semiconductors than it does oil in dollar value. And this means that this is the currency of the global realm in a way that is sort of unavoidable. And the topic that brings us here today is the paradoxical fact that one of the great choke points in the production of semiconductors is Taiwan, which is also one of the most tense, one of the most fraught and dangerous places in terms of geopolitics on the planet. Because of Taiwan's very evolved fabbing structure with companies like TSMC, UMC that actually make chips. And it turns out that both the U.S., China, and everybody else is reliant on Taiwan. And yet we find China claiming Taiwan as a sovereign part of China and not eschewing the use of military force. And so we're not clear about what actually the future of Taiwan may be. It's a democracy, they have elections, there are all sorts of provocations that may trigger something in the Taiwan Straits. And so we're confronting a very sort of fraught situation. And that's our topic today. So what we're going to do is we're going to start off, we have a really amazing panel here of diverse views, experiences. We're going to let everybody speak for, say, try to limit yourself to 4 minutes, because we have 2 sections and then questions. The first section, we're going to try to just set the stage for you. And I'd like to start with Kirti Gupta, who is at Qualcomm, a vice president, a chief economist, and have you tell us just what is a chip? Why is it so important? And how did we get so snarled up in this incredibly complex global network? I should also say all of these people are on a task force group that the Asia Society with Stanford's Hoover Institution has been convening for a year that will put out a report on what should we do about this question. What's the right attitude towards Taiwan, towards China, and microchips? So, Kirti, take your 4 minutes.
And thanks for having me here with this group of experts and you. I just thought that we agreed. I'll just do a very quick lay of the land. And people talk about semiconductors as the new oil. I know it's not a perfect analogy, but the fact is that the modern economy depends on semiconductor chips. And I just looked at some quick numbers. Each of us use over 2,000 chips a day. They're in our cars, our phones, our coffee makers, our hair dryer, our washer, everything, right? So without those semiconductor chips, you don't have modern economy. Literally, the lights go out, the planes go off. You don't have cars, you don't have anything. So that's the world that we are living in. It is the commodity the foundation on which everything sits and stands. Just as an example, your smartphone has over 200 chips, an average smartphone, and an average car has over 3,000 chips that make it work. So where are these coming from? How does this industry work? If we take a step back and we look at the global semiconductor industry, two facts emerge. One, it's growing incredibly fast. It took 40 years for this industry to become a $500 billion industry. It's only going to take 8 or 10 more years for it to become a $1 trillion industry. So it's going to double in the coming decade. Second, it is incredibly globally intricate, intertwined. If there is an industry that is poster child of globalization, this is it, look no further. As an example, an average chip that you use has touched 46 countries and crossed 70 borders before it, from the conception to production, before it reaches you as a consumer in your hands. And the reason is because the supply chain has many stages, from design and R&D to specialized tools. Even for tools, there are different kinds of companies and hundreds of companies and different processes for the types of tools. Then those tools go to fabs and foundries. This is where Taiwan comes in for the production of the chips, or to put the blueprint design onto the silicon wafer. Then there's assembly, test, and packaging, and then many other stages before the chip is ultimately produced and done and sent to the consumer. All of these different stages are happening in different countries. Across the globe, there are hundreds of companies involved, literally, in every one of these design stages. So there are many choke points, not just one, but we are really focused these days on Taiwan because, as an example, two-thirds of the chips produced globally come from Southeast Asia. And 95% of the chips on the leading nodes, the super cutting edge below 10 nanometer, are made in or manufactured. The foundry part is in Taiwan. So again, there are many other choke points. For example, there are lithography tools that are needed for running these foundries that only come from the Netherlands. That's a choke point too. But we are really focused on Taiwan because of course, the geopolitical environment, and also because making and establishing these foundries is hard work. You can't just do it right away. Like, it takes years to build it, and then it takes few more years to run them at capacity. So it's a difficult part of the value chain to enter and build. I'll stop here, Orville. Hopefully I was...
Okay, thank you, Kirti. Philip. So Philip is a professor of engineering at Stanford, has served as a vice president at TSMC, which is the largest fab in Taiwan. So elaborate a little more for us, Philip. I mean, why is this such a delicate ecology, a fab? How did it come to pass that this island off the coast of China, that is one of the hot spots besides the Ukraine in the world, came to be the place where the major fabbing of the chips that everybody in the world relies on, the source of that?
Great question, Orville. First of all, you heard from Kirti that why Taiwan is central. 65% of the semiconductors in the world are made in Taiwan, and 90% of the advanced chips are made in Taiwan. And for advanced chips, I mean that those chips that goes into your high-end cell phones, your fastest computers, your data centers that we all use in the modern world today. And as you can imagine, this is really a foundational technology for the modern society, not only for economic development, but also for national security, for a variety of things. Now, this is an example of how big corporations become extremely important in many aspects of lives, in addition to nations, of course, right? And it just so happened this particular corporation is in a small island, pretty far away from the U.S. So it's just an example of influence of big corporations. It just so happened this is in a small island. Now, Orville, you asked why this came to pass that it happens in a small island. It is, in many ways, it is a success story of the U.S. not just a success story for Taiwan, because if you look at the history of this enormous company by now, that not only the founding of the company, but also the growing up of this company, and even in today's operation of this company, it is strongly based coming from talent and people that are trained in the U.S. All the experience that they gain while they are trained in the U.S., while they work in the U.S., and then work and create this and build this company in Taiwan, many of them came from the U.S. So it's really a unique success story for the United States. Of course, the government policy from Taiwan is far-reaching. 30-some years ago, the government of Taiwan recognized that they need to gain a foothold in advanced technology, and for whatever reason, they decided to invest in this space. And they keep at it for many years, and they have been successful. Now, Kirti mentioned many statistics that shows the importance of semiconductors, and Orville also said that China buys more semiconductors than oil, and a lot of people would compare semiconductors with a commodity like oil. I would like to emphasize that semiconductor is not oil. It's very far from it. Oil is a commodity that will never change. It stays in the ground, you dig it up, and that's it. It never changes. Semiconductor advances every year. You need new generations with technology every year for semiconductors to have this impact that we have been seeing. I would venture to say that nobody wants to have a cell phone that's 10 years old. So if you have semiconductors that were 10 years ago, it's not going to be very useful to you. So semiconductor technology needs to advance every generation on a pace that is at least commensurate with what we have seen in the past, and that is the biggest challenge for anybody who wants to build a business based on semiconductors. Because it's not just getting somebody to build a fabrication plant in a location, but the real question is how do you maintain the relevancy, that plant, that fabrication, that what you are manufacturing, that is relevant to the current day business. And that's the very important point that distinguishes semiconductors from a commodity like oil.
Thank you, Philip. I mean, this is an incredibly complex process to produce a microchip that's in your phone. Edlyn. So Edlyn is trained as a physicist at Harvard and is a co-founder of the America Frontier Fund. And her work has largely been focusing on how things like microchips relate to national security and defense. So talk about the importance there and how that really casts a shadow across the whole global proposition of microprocessors.
Yeah, certainly, and it's certainly a pleasure to be here with all of you. You know, to point the complexity that Kirti was talking about and the research enablement that is required to advance semiconductors are, very close to my heart. My PhD advisor at Harvard was actually one of the initiators of ion implantation technologies at Bell Labs, which are important for creating and fine-tuning the electrical properties of semiconductor devices and transistors that end up in these chips. And so, it is very important to understand the complexity, but also the importance of having innovation ecosystems that combine and co-locate manufacturing with R&D, with advanced universities, that create this type of cascaded ability to share information, knowledge, advance principles, trial them, and move them forward. And that's one of the unique and amazing things about Taiwan's ecosystem, is how very focused and vibrant it is. And to point, talking a little bit about the national security aspects of this, the health of the global economy, to Kirti's point, is really rooted on our ability to continue reliably accessing semiconductor technologies. Our entire digital economy and all these downstream capabilities, artificial intelligence, 5G, high performance computing, cloud computing, all depend on semiconductors. And so in order for our global economic engine to keep running, we need to absolutely ensure as an imperative that that region remains peaceful. And to point, if you think about TSMC alone as a company, they're 4 gigafabs, right? These are fabs that produce, or that have 12-inch wafers. They have 1 million wafer starts a month in those 4 fab facilities alone in TSMC. And if you think about the prospect of those accessing those 1 million wafer starts a month coming offline due to some flashpoint event, that is a prospect that we as a global economy and all of the nations who are participating in global trade, global commerce, need to absolutely work toward ensuring does not happen, that we have peace in the region and we have stable access. In reading, for example, TSMC's 10Ks, right, you'll see in 2021 that they serviced over 500 different customers in the world, producing over 12,000 differentiated chip products in that year alone. Again, this is absolutely an imperative to make sure that that type of commercial activity continues and perpetuates, and that also that research ecosystem remains vibrant and healthy going forward. The reality is that there is concern about, the stability of that region now, and Orville, you had touched upon that, the geopolitics evolving in the way that they have. So there's been a lot of effort and thinking on the part of the U.S. government, what can be done, to work on, for example, supply chain diversification. The CHIPS Act that recently passed has created a lot of press. But the absolute point is that this industry does not move in the time frame of a year. You cannot simply, for example, pick up and move these big innovation ecosystems, these very complicated fabrication facilities to a different region or different ecosystem at the drop of a hat. The evolution of the supply chain is nurtured and developed over time. And that was to point what Philip said about Taiwan's investment in building up their domestic ecosystem has taken in a sustained effort on the part of 30 years to get from their initial foundation of their capabilities to where they are today. And so we need to really think about this, again, globally from the point of view. The first perspective is the acute flashpoint, right? The fact that we have to maintain stability and peace in the region. And the second is, from a longer-term perspective, how do we ensure that we don't end up with these type of, choke point capabilities, right, where you have a tremendous amount of global world commerce, economy development, productivity, and prosperity dependent on this type of flashpoint potentially happening. Those long-term measures are a different category that need to be undertaken simultaneously. But that's the perspective, I would say, from a national security point of view.
Well, thank you, Edlyn. Victor Wong was trained at Stanford in artificial intelligence and is the founder of AimTop Ventures and is a VC in the tech world. But I should also say Victor has the sort of amazing ability to be soluble on both sides of the U.S.-China divide. And maybe you could tell us a little bit about how you view that divide. I mean, the U.S., China, Taiwan triangle. And give us a sense of just how dangerous it is, or how you think it came together.
Wow, this is beyond my pay grade. I'm not a geopolitical expert, just from an investment point of view, because I have many friends. We invested primarily in Silicon Valley. I have many friends investing in China, so I know a little bit about both. I think what happened, especially with respect to the semiconductor, is that given that it's very clear that the U.S. government will, continue to cut off the semiconductor technology export to China, Chinese government already had their policy to be self-reliances. So China, I think China's policy today is very clear that they will basically build entire ecosystem for themselves, zero dependence to the outside world. I think that's a long-term goal. How long will it take them to achieve this goal? Whether they can achieve eventually this goal is a question. But that's clear their goal. But like Kirti just said, this is a very, very hard goal to achieve because you rely on, basically in this ecosystem, there's like 7 different layers from IP core to manufacturing to material to contract manufacturing to packaging and testing and the 2 electronic design software. So you rely on so many, even TSMC themselves rely on many other different countries. If a U.S. company, the EDA software company does not supply the design software TSMC, TSMC would not be able to produce any chips. Or if Applied Material or MSL does not apply manufacturing equipment to TSMC, they will not be able to. So no country today can completely self-reliances. So this is extremely hard goal. So that's one situation that the Chinese government already set that goal. I think also including a lot of investment community putting a lot of money into that, because to replace a foreign export, that's represent a large market opportunity. I think China today import about what, $200 to $300 billion worth of a semiconductor. That's a huge market for a company to take over. I think that's one side of a situation. The other side, like I said, the Western, U.S. government is trying to basically cutting off the export to China, especially for the advanced chips, advanced manufacturing capabilities and design capabilities. So it's very unfortunate that the globalization is the way it's supposed to be, that each country doing whatever they're doing the best. But given the geopolitical situation, I think in my opinion, for the next foreseeable future, that this semiconductor industry will have to be divided into 2 parallel worlds.
So in effect, I think what we are witnessing is a slow fraying of the world in which we've become accustomed to living, of globalization, where it didn't matter where things came from, as long as they were made well, they were supplied cheaply and came quickly to market and could keep inventories down. And I think, Victor, what you're suggesting, and all of you indirectly, are that this world is in peril right now. And the new world is not yet evident, but it's going to involve much more autarky, much more self-sufficiency, if not in countries, at least in blocks of countries. So we move to the second part of our discussion, that if that is the reality, and we all recognize all the choke points. We recognize that there's increased sort of adversarial attitudes between China and the United States and blocks of allies. Then what are the remedies? Where should we turn for solutions? How do we position ourselves in a way that is to maximally at least our advantage, the United States and its allies, if not the globe's advantage. Kirti, let's start with you, because your company is deeply involved on all sides of this divide, and it's going to be a very difficult task to reposition.
Yeah. So Qualcomm is the largest fabless semiconductor company in the world. Fabless means design. So the fabs and the foundries, we're their customers. So from our perspective, it's a good thing to have resiliency. So I'll set that aside. just so you know that there is no sort of incentive to say that their fab should be here or fab should be there. It doesn't matter, basically. But from the public policy perspective, let me appeal to the consumers inside you. I'm an economist. Globalization is a good thing. We've all enjoyed lower prices basically because of globalization over the last 40 years. Understandably, the world order in which we are going to live in, or we are already living in, is different. So how do we adapt to that? And I have two suggestions. One is that as this shift happens that you were describing, Victor, one is China's goals of separating itself and becoming self-sufficient, and US's increasingly aggressive export controls. I hope that we can limit and contain those continuously, because nobody can be self-sufficient. There's not a one country in the world that can operate independently in this global supply chain. The moment you look at the supply chain of 7 different layers and you realize there are hundreds of companies operating in each of them, and there are several choke points. TSMC can't operate without all of these tools either, or the materials, and so on and so forth. You realize that extricating that is basically a trillions of dollars projects that no country basically has the capacity to create, produce, and execute in a timely manner. So let's minimize the separation. And second, as the separation is happening, is inevitably happening, let's create the right multilateral alliances so that we can create at least a resiliency plan that isn't overlapping so much. In other words, if you have to live with overlaps, right? Like there's not just going to be TSMC in Taiwan that will produce these chips. Intel in the US will do the same thing. Maybe some foundry in Mexico will also do the same thing. So there is replication happening to create resiliency, right? I'm an economist. Again, to me, that means prices go up because you're creating inefficiency. Let's at least minimize that. Let's at least find the right multilateral groups, allied groups of countries where we don't overlap our capabilities. So, US and Europe don't have to do the same thing. They can complement each other and so on. So those would be my two suggestions.
Philip, what are your thoughts about what the next phase of this drama should look like or could look like?
I think there are two aspects that I wanted to bring up. One is from a kind of supply chain resiliency and security point of view. The other one is the keeping the industry healthy and advancing the technology point of view. On the first point, this item out in there, we all talk about how kind of dangerous of being a flashpoint for conflict and so on. But I think there are other examples like that, and we deal with that in a different way. Look at the Middle East. There are bombs blowing up every day almost, but we don't stop investing in Israel. So
And the oil keeps flowing.
Exactly. So I think there are other solutions than saying that we don't manufacture in Taiwan. There are many other solutions. For example, keeping the region safe, making sure that it's safer than it is today. And I don't know what those solutions are. I'm not a political scientist, and I'm sure that there are other people who think more about this than I do. But I think the solution is not so much to say avoid doing things over there, but rather than keeping that region safe. Second point about technology advancement, I mentioned that nobody wants a cell phone that is 10 years old. These technology, especially semiconductors, these are advanced on a constant basis. And we're all familiar with the process flow from research to development to manufacturing. And today, 90% of the advanced chips are manufactured in Taiwan. That means lots of the research and development are done in Taiwan today. And that's how they get the most advanced technology. So for a set of allied countries that would like to have supply chain resiliencies in manufacturing, if you walk backwards, that means this allied group of countries or like-minded countries needs to collaborate in research and in development. And research and development are performed by people. So, okay, well, I'm in the education business, so educating people is very important. So for us, one of the main things that we need to do is to ensure that, number one, we have a good supply of talent. The supply of talent, actually there are two pieces. There's the supply side of the equation, there's the demand side of the equation. We're often familiar with the supply side of the equation, provide more scholarships for students who study semiconductors or STEM in general, or providing facilities and things of that, and developing courses. This is all on the supply side. What's less talked about is this demand side. You need to have students who want to be trained in those areas. We need to have students who want to take those scholarships. And what makes those students want to do that is to have a very healthy industry so that they know that they're entering a career that is vibrant and growing, and an industry that's growing, and they have a good career opportunity. So these things are going to go hand in hand. You need to create a very healthy industry to attract the students. That's on the demand, that addresses the demand side. You also need to work on the supply side to make sure that educators, schools, universities develop the appropriate programs and courses to in the STEM fields, in semiconductors in particular. And those are really important things to have. And if you look at university campuses today, a lot of attention has been focused on what I would call save the world. Climate change, very important problems, but and environment and equity, diversity, and ethics. Many of these things are very important problems, but the solutions to many of these problems rest on foundational technology. And I think it is time for university campuses to go back to the basics as well. Not to say that we ignore societal challenges, but to say that we also address these foundational basics.
Thanks, Philip. Edlyn, what are your thoughts about how to address this changing world?
It's a very complicated issue, and I have to agree. From what Victor had said about policies, for example, that China has implemented, that they want to have, their own self-sustained ecosystem, that the global semiconductor industry is now reacting to the reality of a potential schism, basically, in the world. U.S. policies around export controls, trade, et cetera, are also accelerating this type of dynamic. We end up having less benefit from the type of global exchange that Kirti mentioned enables efficiencies in the world and in this type of high-tech industry. And we're facing this acutely now, right? It is something which is affecting our world in the investment community. It's affecting the corporate world. It's affecting the education and research world. All of us are trying to react and to really figure out and navigate this rather potentially volatile space. Again, the first set of policies, if you think about what, for example, governments can and should be working in this area, the first set of policies, I think, doubling down on what Philip had said, is to ensure that peace is sustained, right? That there is a scenario where the world does not see a war break out in that region. And that's the vision, that's the world that we should all be working for. Again, the policies, national security experts, foreign policy experts who have that as their domain should be focused on how to ensure that that's the future that we see. I would say then as well, from my perspective, countries have a lot to learn from, I would say, from Taiwan itself on what good policy to create advanced industries actually look like. If you think about, for example, the United States, and again, I mentioned policies our government has undertaken in terms of, implementing the CHIPS Act, which is subsidy heavy, et cetera. The CHIPS Act doesn't actually address any of the root cause reasons for why this industry globalized to begin with, right? The birth and inception of the semiconductor industry was here in the United States. There's a reason that the region we're sitting in today is called Silicon Valley, right? But the question is how much silicon is actually made in Silicon Valley today? Negligible, none. And there is a reason for that, right? And part of it is the United States did not proactively create a policy environment that enables high-tech industries that have high capital expenditure costs to actually efficiently operate here. And there were other opportunities, for example, taking advantage of low labor costs. At the time, Fairchild Semiconductor was the first U.S. company that started to do packaging activity in Hong Kong back in the 1960s, taking advantage. At that time, packaging, even more than today, was a high labor intensive portion of the supply chain. So taking advantage of low labor costs was economically advantageous and creates those wonderful economic efficiencies that allow us to buy cell phones and computers at the price points that are available today. But the United States itself, if we think now about the efforts behind the CHIPS Act, you read, for example, about TSMC's building of its fabrication facility in Arizona. They're very public about saying that the building and operating of a fab in the United States costs much more than building and operating the equivalent fab in Taiwan. And I think from a policymaker's perspective, the question you have to ask is why? Right? Some of those, are associated with the fact that we don't have the, economies of scale in this country. We've lost a lot of economies of scale with regard to constructing these facilities and then, getting the talent associated with them. But there are other things which are policy related directly. For example, that our tax system is not efficient for capital intensive industries. The fact that, our regulatory environment is prohibitive often to the operation, right, to the approvals and operation of these facilities. And those are things, again, that these companies, as they're considering, if you think about TSMC, UMC, SK Hynix, Intel, where is this company going to build its next fab? When you talk to the site selection committees, this is all of the elements that they consider. And so from a policy perspective, this is, again, what the U.S. has to learn potentially from Taiwan in terms of doubling down on policies that focus on what I would call value capture as opposed to only value creation, which is that research and inception. Most of U.S. science and technology policy has focused on value creation. We'll fund a lot of research, we'll fund a lot of experimentation, but we don't focus on value capture, which is how do you take those brilliant inception moments and actually commercialize them into viable products and technologies. And so when folks talk about industrial policy, which has now become vogue in DC all of a sudden, they should be focusing on how you actually create economically viable, market viable value capture scenarios. And that's a key thing that I think we as a country from a long-term perspective need to look at. And then to Kirti's point, it's not just about the United States. We have to also focus on where our allies focused and doing. What are their strengths and weaknesses? Where is it that we can form partnerships? Because again, going into a world where every country tries to have an entire verticalized supply chain domestically is totally non-viable. We absolutely have to be working at this from a global perspective. So Orville, hopefully that breaks it down. There's the acute near-term policy aspect that we need to be focused on peace in the region. And then there's the long-term aspect where we need to focus from an economic viability perspective, that aspect of value capture for high-tech, capital-intensive industries.
Thank you, Edlyn. Victor, I wonder, how are you as a venture capitalist looking at where investments should go in this highly contentious world where we could conceivably be at war with China at some point? What does that do to your world?
Yeah. Before I answer that question, let me qualify this divide or parallel world. I think this is highly asymmetrical. And rather than two parallel worlds, it's more like China is carved out of this international larger ecosystem. I mean, let's assume China can be eventually self-reliances. But China overall, this ecosystem is much, much smaller in terms of scale compared to the rest of the world. And we just mentioned that China import about $200 billion worth of a semiconductor, right? Today's industry is what, $500 billion, right? Is that China has 40% of market share? No. That counts into, like a Foxconn produce all Apple's phones in China. They import TSMC's chip into China. That also counts as import. But in turn, they export all these phones outside China. So a lot of the semiconductor going through China through contract manufacturing, testing, and packaging. So China itself doesn't consume $200 billion worth of semiconductor. So China is one of the largest semiconductor market, but not that large. So in terms of market, in terms of the total ecosystem, China compared to the rest of the world is still very small. So if China were to be able to achieve this total self-alliances, China would be small part of the parallel world. That's, I need to qualify that. To answer Orville's question, I think the U.S. investment community, I've been in the Valley for almost 40 years. And in the 90s, you see those semiconductor startups popping up almost on a daily basis. Today, semiconductor is no longer a hot deals. Very, very few companies. Yes, there's some AI chips companies here and there, but by and large, they're like a much, much smaller, probably represent 2% of the VC investment today. And so that's one of my concern, that where is the next Qualcomm, next NVIDIA, right? I mean, without these, I think that's what the U.S. investment community need to pay attention to. I think that's number one. Number two is just like Philip just addressed. When I was at Stanford, going to the semiconductor company it's very hot. Today, that's no longer hot for a top PhD or master or bachelor student, right? And so these are, I think these are natural. This is not artificial or man-made. It's just the industry come and go, the different waves. Today, probably the hottest is the AI, right? Everybody want to do machine learning, but that create a shortage of hardware talents today.
And as to investing in China, what's your attitude and the attitude as you read it of Silicon Valley and other investors in America?
Because we're not investing in China, I don't know how to give advice to these people. I know a lot of endowment putting money into the funds into China. I think a lot of companies, a lot of VC fund who got endowment from U.S. invest heavily into China's semiconductor industry simply because that represents a big market opportunity. Mm-hmm.
Okay, so I think we've done our measure of devotion. Let's turn it over to you. I can't see you, but I'm assuming the people with the mics can. So introduce yourself briefly and ask your question, and we'll try to answer it.
Thanks, Orville. Mike Zelenziger from Oxford Economics, although former journalist, used to cover this valley. So I'm going to date myself by saying, I used to say that, and this panel actually shows it, that this valley was always run by ICs. I don't mean really integrated circuits, but Indians and Chinese. Because the value proposition of this value is that Indians and Chinese would go to IIT or to Tsinghua, would come to Stanford or Berkeley or MIT for graduate school, would stay here for many years, often work at companies, but sometimes become sea turtles and come home. So the software question going forward is, does this mean an end of immigration of high-tech engineers to the United States to study? Does this mean more immigration restrictions? How do we prevent this from being another Red Scare? I mean, there are tremendous implications of what you're saying if we are indeed, as Victor suggested, separating into two cultures. Are we prepared for that, and what does that do to the value proposition of this valley?
And what does it do to the notion that America was sort of the go-to research commons in tech fields, of which Chinese became an immensely important part. Who wants to try that?
Maybe I'll take a stab at it. For good measures, I grew up in Hong Kong, so we're already seeing the indications of tremendous decoupling in the research world. Today, I tell my colleagues that education business in university is a very dangerous business, because if you ever happen to have any collaboration with China, it is very dangerous. It's very typical. So many of my friends who have had a relationship with China in the research collaboration have been expressing tremendous distress or concern about these engagements. But if you have some measure of short-term memory, there was a time in which engagement with China was encouraged across the entire academic spectrum. So this change of events has been quite dramatic, and it really put the damper on research collaboration. As I mentioned, research is done by people, and good research, all hallmarks of good research is collaboration. And knowledge has no boundaries, has no national boundaries. So collaboration should be across the entire world. And now we're in this dangerous world, no, not dangerous, but kind of interesting world in which we are separating into different pieces of the world. And that would, similar to the case of increasing cost in the supply chain, this separation and boundaries of collaboration, walls that are set up between collaborations, will certainly slow down our advancement of technology.
Anyone else have thoughts on this?
And adding to what Philip had said, from an investment perspective, a lot of companies that come to our door for venture capital funding are founded by foreign nationals who came here for their educations and who want to stay, and that contributes to our economic activity. And so, I can't read the tea leaves on how, immigration policy will evolve, but I can say it would be incredibly myopic for the United States to discourage immigration of talented foreign nationals to come to our borders.
Yeah. I mean, this is precisely the problem that China has. It doesn't encourage immigration. It doesn't have an international pool of research commons that has really made American research universities and corporations, I think, the envy of the world. Okay, next question.
Hello, Tom Orling from Bloomberg. So the panel has touched on this in a few different ways, but I wanted to sort of ask the explicit questions. Towards the end of last year, the U.S. introduced a ban on the sale of leading-edge semiconductors to China. So I wanted to ask the panel, firstly, do we think the U.S. is pursuing a desirable objective with this policy? Is it desirable to block China's development on semiconductors? Secondly, assuming it is a desirable objective, is the policy introduced toward the end of last year well designed? Is it likely to achieve that objective? And thirdly, what could be some of the unintended consequences of that policy? Thank you.
Yes, and I think just recently, National Security Advisor Jake Sullivan intimated that not just limiting the sale of semiconductors, but that perhaps we need to consider the proposition of not feeding the beast of China's technological advancement. Who wants to try that?
I can take a stab at that. I think it's a very relevant question. I look at those controls and refer to them as double-edged sword, right? Because on the one hand, the policy objective, at least stated by Washington, is to attempt to slow China's advance, and certainly, at least in the near term, the direct access to an advanced technology will slow advance. And people refer to this as a technology choke point. My perspective as a scientist is that a technology choke point is a temporal bound, right? If you're a scientist or an engineer and you know that something is possible to achieve because someone else has demonstrated it elsewhere, you can do it if you're sufficiently well-resourced. And certainly China has put a lot of resources toward its engineers, scientists, tech companies, universities to actually achieve that self-sufficient supply chain and capability that Victor was referring to. So unintended consequences, the biggest unintended consequence that I think might result is the impact to U.S. companies from lack of access to the China market. If you look what has happened historically with export controls in the United States, the unintended consequence has been to hurt the market share of U.S. industry. So an example in semiconductors itself, you can draw from the Export Control Act of 1979, at which point U.S. capital equipment suppliers, so those are the companies that supply the tools that are used in fabs to make semiconductor equipment, had about a 90% global market share at around the time of 1979, 1980. 10 years later, fast forward, and they had lost about half of their market share because they were essentially viewed as vendors of last resort because of the need to get approvals to sell into foreign markets. And so that's a key portion of unintended consequences, I think, that might happen as a result.
Yeah, I mean, I have the same sense that it's a very powerful tool, but it needs to be used carefully because, of course, the objective is to be able to run faster. And it helps in the short term, partly because ultimately to run faster, you need to run faster because others will catch up. That's what you're saying, Edlyn, like there is just a temporal bound. Mm-hmm. But in the meantime, the power of the tool can also devastate the US companies because the foreign competitors can and do step in to take away the market share, thus further weakening our domestic competitive advantage. And we've seen that again and again in the prior industries and also in semiconductors.
And yet, if I may, I mean, there are the question of economic interest, corporate interests, and scientific research interests, but there also is a perhaps conflicting question of national interest, defense interest. And we haven't really talked about that. And Edlyn, that's sort of your field. Mm-hmm. Do you have any quick comments about how we should be positioning ourselves in that realm?
Yeah, that's actually, talking about the objective, right? There is the objective of us wanting to run faster and then, slowing down China's capabilities. Part of the national security concern is, what are again the end-use products that a semiconductor device ends up, enabling? And, from a national security perspective, defense capabilities, like all defense systems these days, have semiconductors in them. And the more sophisticated the semiconductors are that are embedded within your defense systems, the more successful you will probably be. We see that dynamic actually currently at play right now in Ukraine, when you look at the way that Ukraine and Russia have a disparity of access due to Western sanctions to semiconductor devices that enable systems like precision-guided munitions or autonomous drones or GPS or satellite-enabled communications. So those are all elements that need to be considered in the context of national security access. And the concern with China, and one of the objectives then, is to prevent their getting access to leading-edge capability that then end up in end-use systems that could be used in a belligerent manner. The issue, and this again gets into the temporal aspect of this, is that this can work over a short period of time, right? If you block access to an advanced technology, then yes, certainly the country that you've blocked won't gain access to it. But if that enables them, right, that's the galvanization that basically stimulates them into saying, okay, well, if we can't get it from you, we'll create it ourselves, right? In the long term, what you'll end up seeing is technology development in a parallel ecosystem, which ultimately might enable China to gain access to those capabilities themselves. And so it again, it's a near term, yeah, it's really effective. If tomorrow you don't want them to have access to these capabilities, maybe in a year, maybe a 2-year time frame, maybe even a 5-year time frame. If you're talking about an advanced technology like UV lithography, that might be multi-decadal to catch up to. But eventually, right, if enough resource, enough talented engineers, scientists are able to work on a capability, especially if it's one that has been demonstrated before, then the export control is going to be temporally bounded.
Okay, I think we have time for one more question. I see one here.
Good morning. My name is Sherry Gu. I work for ARM. We provide semiconductor IP that goes into chip design globally. So we talked about Taiwan and the rest of the world. I'm just curious what China means to Taiwan in terms of supply chain, end-use markets, and talent exchange, because we know Taiwanese companies have investment, like fab investment in China as well, and there are Taiwanese executives move to China and work for mainland companies. And we just talked about China being the top importer of semiconductors. So what kind of new world trade order that involves China what Taiwan would like to see that's beneficiary to the entire industry? Thank you.
Yes, good question. I mean, we have Qualcomm selling to China. We have TSMC selling to China. Foxconn is hugely in China. What do you all think? How would you answer her question?
I think, Victor, you shared the data too, that I've seen the data that I can take a part of the question, that 35% of the chips that are initiated from the United States in terms of production. So if you look at the entire U.S. market for semiconductors, 35% of the chips are being sold into China. But over 75% are being sold through China. In other words, they're going to China, they're then being put into different products like Foxconn's production of phones and so on, like in different products, and then they're being sold in the rest of the world. And I think the global data looks very similar, that a majority of, a big portion of the chips are, I think you mentioned a number 200 billion, is the size of the market that is mostly passed through China. So it's a pretty strong dependency, I would say.
Any other thoughts by way of conclusion? Well, then let me simply say, I don't think we've solved this problem, but it is indeed a problem where geopolitics intersects with technology, that intersects with markets, where everybody that is in a state of slow dissolution is in effect dependent on everybody else. And that's what makes this such a devilishly difficult proposition to see an answer to. Let me thank our 4 panelists. You've been wonderful, and thank you all for coming.
Thank you, Orville, and all of our speakers. You summed it up well. It's a very complex topic that we cover regularly, so we look forward to the updates, and thank you for all your work on this and for breaking it down in terms that we can understand.